Today we're discussing Lab Project M2. The title is, in the manual, Creating Your First Program and Rung of Logic, or 2. Actually, the or 2 doesn't come into play. It did originally. I just realized that the title, it just should be one rung of logic. And the idea of this lab project is to build on what you've learned so far. So far, we built the foundation, the groundwork for what does a PLC do, what is a PLC literally hardware-wise, including inputs, output, ladder logic diagrams, etc. Then we've gone through some CCW and RS links. So what you have in front of you right now for Lab Project M2 is a computer with software on it, and you have either a hardware controller in front of you or you're using the simulator. Now, in the lab projects that we're lecturing, we're using the simulator to guarantee that if you're learning this without actual hardware, you're not going to have an issue, other than you got no licensed switches. And actually, the simulator works out better in some cases because it has more I/O than you probably would wire up on a hardware learning station. So what we built this all up in M1. You learn about module defined data types, and by the way, I interchangeably will say tags, tag names, variables, pointers, etc. It all is a piece of text, alphanumeric can be, that you use for programming, but behind the scenes where you can't see, it points to a literal memory location, which is strictly a numerical array ID for the memory location in your controller. So anything above that numerical ID is a variable. It's a pointer. It points to. It's a tag name. Now, in earlier years, people called them memory address, and you've heard me beat this hobby horse. Address is really a verb. It was originally a verb. There was no such thing as an address being a noun, except if someone documented an address that somebody was giving to a group or a person and they scripted it. That document could be called the address. In other words, it's a written form documented of the address that was given. How it got to be memory address came from the postal system, because years ago when somebody was writing down a postal location, a town, a street name, and a person's name, they were addressing the envelope. In other words, they're addressing the person with the document that's in the envelope. So the act of writing it, the actual physical location on the envelope, you are addressing that person with that document. Now, if you want to call these memory addresses, that's fine. Nobody's going to split hairs with you, but I want you to understand why I try to stick to memory locations and not say memory addresses, because instructions address memory locations. They either query it or write to it. Read, write, type instructions. Okay, so the rung of logic in M2, it's the simplest rung that you can have. It's got a true if off, and then it's got an energize output. Or in CCW Micro 800 language, it's a direct contact and a direct coil. So if that bit is on in memory, then turn on this bit in memory. It's as simple as you can get. And we're going to squeeze everything we can think of out of looking at that single rung of logic. It's 2 instructions, it's 2 memory locations, and how that ties in with everything that you can see with CCW monitoring that PLC program. So you can either pause, do the lab project if you've not already done it, or watch the video, go do the lab project, come back and watch it again. So let's have at it here. Beginning with the project the way we left it after M1 simulator, and you see up in the title bar, it's still called M1 Simulator. I'm going to save the project with a new name, and I'm going to call it M2 First Program, First Rung. It's not a bad idea to give each project a name besides M1, M2, M3, but one that kind of gives you a clue what you did in that project. So here we have the old project, and now we're going to add some things. First thing I had to do was to add a program. So you go to Programs, right-click, Add. This platform supports 3 languages: structured text, ladder diagram, and function block diagram. We're going to stick to ladder diagram most of the way through this course, but we will do some structured text and function block diagrams at some point. Ladder diagram. So you see now it creates one called Program 1, and it's got local variables. I'm going to double click on Program 1, and you see it added another tab up here. I have 3 tabs now. I have the start page, the controller itself, and then Program 1. I'm going to double click on local variables and add yet another tab. Now I have 4. Double click on global variables, and now I have a 5th tab. Not doing the lab in the same order that was in the manual, but what I wanted to do was to show you how to move these different displays around. So I'm going to reduce the size of the workspace, and then I'm going to unpin and then grab this and drag it over here up in the corner, resize it, collapse it down a little bit so we've got some space to share with other tabs. Now I'm going to grab the program variables and unpin, grab it, drag it over here, collapse it horizontally, and collapse it. Give me a hard time there. I'll just drag it down this way and then drag it back up. And then we've also got the micro 850 and the start page. We're going to leave the ladder logic where it's at, but I'm going to grab the micro 850. Notice that when I changed the pin status, it jumped over to the beginning. Now I can't pull it down to where I want it, so I'm going to have to first resize it, drop it down in size. I'm going to leave a little more space. Matter of fact, I'm going to collapse this some more. Since we're using the simulator, I need some space to show the simulator. Now if you're using a controller, a hardware controller, this is not a concern for you. And it doesn't matter if it overlaps a little bit. Okay, the next thing that I had you do was to add a rung. And we have a rung here, but we need to add an instruction. Okay, this is a direct coil or output energize. Now this instruction menu up here did not exist in version 10. In version 11, you could get this if you had the developer edition, and then it's standard now in version 12. So if you're working with the standard edition, you have this RS Logix looking instruction menu. But in the manual, we primarily use the toolbox. And we went to the toolbox to get the different instructions. The one that we want right now is a direct coil. So I'm going to grab it off of there. Whenever I see the plus sign pop up, I can just let go of it and it's going to pop in there. However, this instruction is not associated with a memory location yet. So I'm going to type in a name, my first bit. And the scope shows global scope, program, local scope, program 1. So we're going to leave it as is. See, local variables are selected here. Notice this tab is white and the others are gray. If I wanted to put this in the global tags right this instant, I could click on that tab and now it would go in the global. See, local scope, non-applicable. Go back to local variables, program 1. I'm going to say OK, and by the way, it's a Boolean, and it comes up by default Boolean simply because the instruction that we just added is a Boolean type instruction. Say OK. Now notice that over here in our program variables, we now have my first bit. If you hit X here, you're going to remove the toolbox from the graphical user interface. You don't want to do that. So just click anywhere off of it, it'll disappear. Then I had you, after you added this rung and added a local tag, then I had you download it. Remember, we're working with a simulator now, not an actual hardware controller. So the first thing I have to do is to start the simulator. What that does is it creates an instance of it in memory, but it's not running yet. So it's like, okay, I have the controller now, but it's not turned on. Next thing we need to do is to turn it on. Now, I'll point this out right now. Synchronize the module configuration. We don't need to do that because we're using the bare bones 48 I/O simulator. There are no additional modules that have been added. But let's say that we had added a module, a plugin or even a add-on expansion. Then we would need to do this, synchronize the module configuration. We'll go ahead and do that. The module configuration of the Micro 800 simulator will be replaced. Continue, yes. It got replaced with exactly what it was, so it didn't change. But always make sure you do that if you have added modules. Okay. Our start button now is exit if we want to exit it. But yet again, we don't see it, okay? And that's because it got dropped back behind all this other stuff. That does present us with a challenge. And the way that I'm going to resolve it, at least for the moment, is I'm going to collapse this up a little bit and bring this over. Maybe I'll go up a little bit further. Don't want to go up too far. And if we bring this over, whoops. Okay, now we have the full Rung in view. We have our simulator in view. There's no power on it. And to put power on it, I can go up here and turn it on. Or I can just click here to bring this to the top. See, this part's covered up. So I'll turn it on. We're powered up, and that's it. Because we have a path, and to make sure that we have the path, let's go over here and look. Look at your Micro 850 display over here. See, you've got an Ethernet path that we configured before. So I can say connect here, download current project to controller. Well, we know we don't want to upload because whatever's in there is not what we just created up here in our ladder logic. So we definitely want to download. This takes a little while. It has to build or compile. And then we have to pick what kind of download we want. Download just the program or download the program and all the values in the tag databases. Well, we really don't have any, not online or offline, so it really doesn't matter. But in the future, you have to keep in mind that your offline project, and there are really actually only offline projects, but in your offline image, you have values for timers, counters, integers, real values, all kinds of stuff. In the controller, if there's already a program in there, that program and that data table in the controller also has values. So you have to decide whether you want to download just the program, which will not alter the register values in the controller, or you want to download the program and the register values that you have offline, overriding the ones you have online. Really is not going to make any difference here, but I'm just going to say download because it's a little quicker. Download is complete. Change to the remote run mode, yes. Now, you'll always get this message with the simulator. For you, it's going to be 10 minutes if you're using the free version, 1 day for me. Now, this is something that I don't like, is that it rearranges everything. So see, here's my output window. And by the way, I can unpin this. I'm going to unpin this just long enough to bring it out here and drop it down so you can see everything that's there. There's not much there. Now I'm going to bring it back in, put it back where it was at. But I'm going to close it because I don't want to eat up the Rung space. I don't need this device toolbox, so I'm going to close it, and there's my Rung. Because I distributed all of these windows offline and then downloaded, now I got to do it all over again. So here's your Rung of logic. Then what I had you do after you downloaded the Rung and put it in the run mode, then I had you toggle this bit off. Right now this is red. Red means true until you get to here. Here, red means on. So everything from here over is true or false. Everything from here to the right is on or off. If you look real close on in your program, you can't see it on my screen, but there's a little darker red rectangle right there where my cursor is, right there. That's the separation between the Rung out from the everything to the left and the Rung in to this instruction. The Rung in to this instruction is true Rung in, or Rung true in. It sets my first bit to 1. Now if I toggle this in this mode, it does turn it off, but it goes right back on. If I go up here and uncheck logical value, see it goes blue and then it goes right back red again, because every program scan, and that's thousands of times per second, it executes this rung of logic and tells my first bit you're on. So if this program executes 3,000 times a second. Then 3,000 times a second, my first bit is being told in memory that you're on, you're on, you're on. Now remember, on the third scan, it doesn't know, it already told it that it's on the last two scans. On the millionth scan, it doesn't know that for the first 999,999 program scans, it said it's on. Every single program scan, this is going to be told it's on. This type of instruction has a true execution and a false execution. It does something to my first bit in memory, which is right up here, when the rung's true and when it's false. Then I had you put it in the program mode. So you go down here to the micro 850. You can see now why we like to lay this stuff out like this to make it a little bit easier so you can see everything that's going on all at once. I had you take and go back here and toggle this off. We're in the program mode, remote program mode. Now, something I want to point out with RS Logics and with CCW, where you put your mouse to toggle it is a little bit different. Okay, now that time it took toggle Boolean bit. So what I did was I just told that bit in memory that it's off. I toggled it to the opposite state. And I can do that at the ladder logic, or I can do it here. See? Same effect. Now the reason that this is blue is because that bit is off in memory. Remember, I'm online right now, right? We got this puppy running. This is just like a real controller. And if you had a real controller instead of the simulator, everything would look exactly the same, except you wouldn't have the simulator down here. Because I'm in the program mode, this rung of logic is not getting executed. As a matter of fact, none of the programs, if there were more than one, in this case there is one, so when I say programs, I mean anything under this folder, none of this is getting executed when you're in the program mode. If I put it back in the run mode, keep your eye on my first bit there. See, it's back red again. And if I go here, see, it turns blue and back red. The graphical user interface does acknowledge the fact that you told it to be in the opposite state, which is off, but then the very next program scan, it changed it back to on. We toggled the bit off, we toggled it on. Then we had you disconnect. The easiest way is just to go up here to where it says connect and click on it. See, it says click to disconnect. You can also go over here to your controller and disconnect from there. Same. Then I had you add another instruction. Now I'm going to add it from the toolbox here, just so you see enough of this over here. And what I'm looking for is a direct contact. I call these true if on. Now we have to add a memory location for this instruction to address, which I'm going to make it my second bit. And I'm going to leave it in the local scope. Okay, I'll click anywhere in here to get rid of that toolbox or to close it back up. Remember, you don't want to hit the X because it'll disappear from here. Then you have to go to your window and you have to do a reset window layout, and that's going to mess up everything. Try to avoid, when your toolbox is open, closing it with the X. Just click in an empty screen space to get it done. We added this true if on. In other words, this instruction is true if that bit in memory is on. And if you look real close, you can see a darker black here, one here, one here, and one here. This is the rung out state transition right here from this instruction. And this is the rung in state to this instruction. Even when these are red and blue, you're still going to see these little darker marks. Knowing where they're at does come into play when you're adding instructions. You can't add it inside between here and here. You just have to be conscious of this. Believe me, after a while you won't even notice. So I had you add this, the local tag and the instruction, then I had you download it. Now the easiest way to download is just go up to here and hit download. I could have also done it over here on the controller. And of course it's going to build. That always takes a little bit. Back to the run mode. Okay, so here we are back running. I'm going to close the output window. I mean, I could scroll it up and down so you can see what's there. We don't want to waste our screen space with this. We have this downloaded, and in your manual, it told you to take note of the color of the rung lines compared to the earlier color in the run mode. Well, earlier this was all red, right? But notice there's still a little red right there at the beginning of the rung. That is because this power bar, if you want to call it that, it gives every rung a rung true in state. At this point, the rung is true right here. Now the state of that bit in memory, because this instruction is making a statement that says, my second bit is on. Well, it's not on, therefore this is false. Right here, you get a rung out false. And if you got an out false here, you got an out false in here. And this instruction, which has a true and a false execution, is telling my first bit, you're off, you're off, you're off. If this program scans 3,000 times a second, then 3,000 times a second, this rung is telling, through this instruction, this is false, and the false execution is telling my first bit, you're off, you're off, you're off, 3,000 times a second. So keep in mind this has a true and a false execution. That's very important to remember later on when we look at some other instruction. Now if I go up here and toggle my first bit on, you see it changes to red sometimes. Try it here. And right back off. So it was actually on. It does actually go on in memory. At the end of the scan, it's off. As soon as this rung executes, it's going to turn it off. And remember, what you do from your mouse and your keyboard, at least greater than 1/4 of a second to a 1/2 second. What the processor is doing is at least 3,000 times a second. So believe me, the processor is faster than your mouse click. We had you toggle that on. Now we'll toggle this one on, and we can do that from here or here. Doesn't make any difference. Typically, I don't go to the variable display to do it. I just right-click here, toggle bit. I just toggled that bit on, and then the very next program scan, this instruction was true, the rung out is true, the rung in is true, and it tells my first bit it's on. I can go here, toggle it, and it goes blue, but right back red because the rung is true. In the manual, roughly on page 83, uncheck the logical value box of my second bit, or toggle the variable again. What happened? Well, rung's false. Did you uncheck both boxes or just the one instructed to? Well, that's just to remind you, you should have only unchecked one. What happened to the state of my first bit when you toggled off my second bit? It went off. If I toggle this off, then my first bit goes off. With both bits off, and of course I can do that, my second bit, I can toggle it off right here. Now remember, these aren't inputs and outputs. These are just true-false instructions and read-write or write instructions. We're not using the inputs or the outputs. We're all working internally. And this is important to understand because these global variables here, like digital output 0, it is controlled by that actual screw terminal is controlled by this bit memory. This is just a bit memory. This is not an output. I mean, you can call it an output if you want, but it's not. It is a bit memory. That is the address of that bit memory. And if you turn that on, and if the program's running, then it'll turn that output on, output 0. We can scroll down a little bit so we've got some inputs and outputs here. This is a bit memory that if you're in the run mode will control the screw terminal for output 19. This is a bit in memory that is controlled by the state of the screw terminal in the run mode, the input screw terminal. Okay, I said with both bits off, check the physical value of my first bit or toggle it. Question is, did the rung display any change? Yes, it did. What? It went to red and then it went back to blue. Did the physical value remain in the on state when you checked the box? No. Why? Rung false in sets the bit off. Then we had you toggle my second bit back on, and of course that makes the rung true, right? And then I had you switch it to the program mode. It says, if the controller is in the program mode, is this rung of logic executing? No. Now look at it closely. You can see down here, we're in the program mode, right? Up here, you really can't tell. That's one thing that I think is missing from this display, that it's not real obvious that it's in the program mode, but down here you can see it's in the program mode. Click on the controller tab and switch the controller to the program mode and view this. If the controller is in the program mode, is this rung of logic executing? The answer was no. So I repeated that. Looking at the color of the rung lines, would you know if the controller is running or not? Right here, no, you wouldn't know. As far as you know, it's running. because what is there makes sense. If this is on, this is true. True rung, true execution, it turns on my first bit. And this being red means my first bit is on. Is it actually on? Yes, it is. Look up here. See, they're both checked, logical value. Okay, then I had you undock the controller page, which I already did earlier. Then I had you switch the mode while watching this rung right here. Switch the mode back and forth. You see any change? Back to the remote program mode. See, no change. So the question was, while watching the rung of logic, switch the controller mode back and forth between program and run. Did you see any changes in the rung color? The answer is no. In the run mode, toggle the state of my second bit. Now this is in the run mode. In the run mode. Okay, so we go back to the run mode. Toggle the state of my second bit back and forth between on and off while watching the state of my first bit. Now I can do it up here. So we went back and forth a couple times. Does it appear that the state of my second bit controls the state of my first bit? Yes. Now you may think that's an obvious question with an obvious answer, but I want to cement in your mind that the false true condition of the rung controls the bit that output energize or direct coil is addressing. Switch the controller back to the program mode. We go down here, program mode. Did the state of either bit change when you switched it to the program mode? No. Let me do that again. This may not have been in the lab, but just for grins. Okay, I'm going to turn my second bit off and then do the same thing. So you see, it doesn't matter whether this rung was true and that bit was on when you went to the program mode or false and off. Nothing changes. So you can't look right here and tell whether or not it's running. But if I click on my second bit, I see the rung's true, but my first bit's not on. That's a clue right there. You're not executing. Or I can turn on my first bit. And you're thinking, wait a minute, the rung's false. Why is that on? You see what I mean? So if I turn on my first bit, you know it's not running. Watch what happens when you put it in the run mode. It goes to off because the rung is false. So the answer of did the state of either bit change when you switch to the program mode? The answer is no. In the program mode, toggle the state of my second bit back and forth, on and off while watching the state of my first bit. In the rung and in the data table checkbox. In other words, I'm saying toggle it back and forth in here and up here. I had you toggle the state of my second bit back and forth. See, rung's true. Okay, we're in the run mode, so let's go to the program mode as I instructed you to do in the book and do the same thing again. So it changes the look of the rung, but because you're not executing the program, it's really irrelevant. Does it appear that the state of my second bit controls the state of my first bit? No, not in the program mode. So we summarized a few things, and we've already done that. While in the program mode, I had you turn on both of these bits. It looks like the rung's true and this bit is on. Well, the rung's really not true, but both of these bits are on. This looks true because it's on over here in memory. So I had you, while watching the rung, both bits check until you have a solid understanding of the relationship between the state of a bit memory and how an instruction in a rung is presented in the two states. Then, while watching the rung, both bits unchecked, switch to the run mode. Now you already know what's going to happen. Nothing. Because the rung's not true. We switched that bit off. Did anything change? No. That's because the rung not true. Rung is not true. Now, as we had both bits unchecked, in the program mode, it was all blue. When we switched to the run mode, they stayed blue because neither one of those bits is on. Then I had you switch back to the program mode and then check my second bit. So I'll do it up here. You can see that this instruction is true in a sense, but the rung's not true because it's not being executed. Did anything change? Yes. Why? Because you made my second bit true. or rather I should say that my second bit is on, so the instruction is true. Switch back to run, leaving my second bit checked. Okay, so keep an eye on my first bit when we go back to run. See, now it's on because you're executing that rung of logic. So then I had you uncheck my first bit in this state with it running. Uncheck my first bit. Did anything change? Yes, it did. You got a temporary off for my first bit, but it didn't stay off. In the run mode, toggle the logical values to create the following images in the run mode. Well, we uncheck my second bit, right? And then we toggle my first bit, and momentarily you're going to get that. Okay, that's the first image. That's the first image, that's the second image in the manual. In the manual, ask you, why do you see the state of my first bit is temporarily on? That's because you toggled it on. Then it went right back off because the logic turned it off. In the run mode or program mode, who controls the state of my second bit? You do, with the mouse. You're the only one that can control it. Nothing else controls the state of my second bit. In the run mode, who controls the state of my first bit? My second bit does. The state of my second bit, because of the true if on instruction, it controls my first bit state in the run mode. In the program mode, who controls the state of my first bit? In the program mode, you do. Because in the program mode, that rung is not being executed. The only thing that could possibly change the state of my first bit is you, with mouse clicks. The last thing that I had you do was to move these two variables from the program variables to the controller variables, or the global variables. So I'm going to go down to the end. Actually, before I do this, I'm going to disconnect. I'm going to disconnect, and then I'm going to take and put this back over here. Go down the bottom, see, so now I have a open field down here. I'm going to drag this up a little bit, and I'm going to drag my mouse across these two tags. Control C. I'm going to go down here, Control V. Now you see I have those two tags in the global variables. I'm going to go back here and delete them. So, okay, so I just moved those two tags from the local to the global. That was the last thing that we did in this lab. M2, your first program and first rung of logic. One more thing I want to show you real quick. Once I move those two tags, or those two variables, from the local to the global, now look at these instructions in the program. When they were originally instantiated, my second bit was a local and so was my first bit. So now these instructions are complaining that they can't find these variables. So if you go up and right click, variable selector, see it disappear. You really didn't have to do a whole lot. Just variable selector, click on global, and OK. Now it's good. One more thing to pay attention to, those yellow triangles say that they don't like something. What did we do in this second lab, M2? You created your first program. That's a structure that holds both your code, whether it's in function block diagrams, structured text, or ladder logic diagrams. We're doing ladder logic diagrams. And then also it creates a subfolder for any tags or variables, as they call them, that belong strictly to that program. What we did was we poked around in that space and demonstrated the difference between what you see when you're in the program mode and when you're in the run mode, and how those two modes of operation affect not only what you see on the screen, but the state of the bits in memory. So in these first two labs, we are slowly walking you into the environment of Connected Components Workbench with a Micro 800 controller. First, we have to establish what you're seeing on the screen and what it means. Always remember, there is no such thing as an online program. There are only offline programs, and when you go online, you're taking the data out of the controller's memory and you're using it to animate the ladder logic diagrams that you're looking on your screen. Ladder logic diagrams do not exist in the controller, nor do function block diagrams or structured text. What gets downloaded to the controller, it is a if you want to call it, it's a program, but it's in machine level language. So what you're looking at on your screen is a graphical representation of the logic that's in the controller, animated by the state of the bits and words in memory of the controller. Now when you go offline, then you're looking at the state of the bits and words in memory that you have offline in RAM, the RAM of your computer. Since we're using the simulator, don't get confused here. There are two areas of RAM at play here. There's the RAM set aside for connected components workbench, your project, and then if you instantiate a simulator, in other words, you activate a simulator, that's another section of RAM. So you have two identical structures, one for CCW and one for the simulator. The values in those may not be the same because when you're running the simulator, you're changing some of those values. And what you have offline in the other chunk of memory isn't going to match unless you upload those values. Vice versa, going the other way. What you create offline, if you download it to your simulation, but you don't download the variable values, then you will overwrite what was in the simulated controller with what you had offline. We'll keep working on this until you get it. Okay, M2, your first rung of logic. What you should walk away from this lab project is a very comfortable, firm understanding, not just knowledge, but also understanding. There's kind of an old saying that with wisdom get understanding, and with understanding get prudence. Wisdom is doing things that you don't necessarily understand why they work. It's just wisdom to do it that way. Understanding comes because after you've applied wisdom and it brings about a good result, then you start to understand why that wisdom bears fruit, good fruit, okay? Why there's a good result. Think about this. If you apply wisdom and you gain the understanding, then you will have prudence. Prudence is being able to see the outcome before you take the action. Like, I can see what's going to happen before I even open my mouth and say it. I can see what this rung of logic is going to do before I even write it. So what we're gaining here is kind of I can see what's going to happen before I write this rung of logic. That's why we start out with a simple rung. We kind of exhausted 2 bits in memory. You know, it's either on or off, right? And then you have 2 instructions. Now remember that the direct contact, which in other platforms they have other names for it, I call it true if on. The instruction is true, logically true, if that bit in memory that it's addressing is on. And then your write instruction, direct coil or energize output. It's not really an output, but it looks like a relay coil. That's just simple. If the rung's true, then that instruction turns that bit on that it's addressing. If the rung's false, then it turns it off. So we just pretty much exhausted everything you could do with a single rung of logic, online, offline, etc. Now we're going to, in M3, we're going to jump to what happens if you have more than one rung. Is there a relationship between 2 rungs? In M2, you looked at the relationship between the instructions in a rung of logic and the bits in memory, online, offline, etc. In the next lab, you're going to mix it up a little bit and have more than one rung to see what the relationship is between the 2. So thank you for your attention, and we'll see you in M3, ladder logic diagrams.